Good evening, ladies and gents. Welcome back to our amazing science tutorial videos. I'm Coach Spivey, joined my son Jordan Spivey. And if you're new to the channel, go ahead and like and subscribe so you don't miss out on any of our amazing science tutorial videos. And also, go ahead and check us out at www.fathersoninnovations.com so you can see more of our great and amazing content. And I'll go ahead and leave a link in the description below. But without further ado, let's go ahead and get into our video for today. So we're going to be taking a look at Density 101. So let's get started. So let's talk density. And density is basically how tightly packed matter is in an object. And density is measured in grams per cubic centimeters for solids and then grams per milliliters for liquids. And it's important to note that cubic centimeters, the reason why we have that 3 right there is because we're looking at length times width times height. So we're looking at those 3 units for that. And then water has a density of 1 gram per milliliter. So objects with a density less than 1 will float because their particles are less tightly packed than water. So for example, say if these are the particles of water right here, so I'll label it H2O. And then if these are the particles of an object, so say if it's like the particles of this sponge right here sitting to the right. And so here are the particles of the sponge. You notice that these particles are more spread out than these water particles, which means that this sponge is going to float on top of water because it has a density less than 1. So say for example, if it had a density of 0.86 grams per cubic centimeters, that means that that sponge is going to float on top of water because its density is less than 1. And then the same thing can be said for objects with a density greater than 1, and they will sink because their particles are more tightly packed than water. So we take a look at this brick right over here to the right. Let's go ahead and draw those particles for that brick. So if it's a brick, that means those particles are going to be tightly packed. So here's our grams per cubic centimeters, and let's say that brick has a density of 5.73 grams per cubic centimeters. And then if we draw the density of water again, and if you notice, these particles of the water are more spread out than the particles of this brick right here. And that's what's going to cause that brick to actually sink in water because it has a density greater than 1. So now let's take a look at mass and volume. And mass is simply how much matter is in an object. And mass is measured in grams. So for example, if we take a look at this bowling ball right here, this bowling ball, even though it's smaller than a lot of other objects, this bowling ball has a lot of mass. Why? Because its particles are very tightly packed. And then we take a look at volume. Volume is also simply how much space an object takes up. And volume can be measured with length times width times height. So we look at this rectangular solid, we're looking at the length times the width times the height to get the volume. And that's where we get that cubic centimeters from again. Remember, because we're looking at those 3 units, and that's where that 3 comes from right here. And then volume is also measured in grams per milliliters for liquids. So we take a look at this graduated cylinder right here, we end up getting 800 milliliters of liquid. And now let's go ahead and take a look at our density equation. And the density equation is pretty simple. It's just D equals M over V, which stands for density equals mass divided by volume. And we can use this magic triangle right here to the right. Notice that if I cover the D up, then I have M over V, or mass divided by volume. But say if I want to solve for mass, if I covered our M up right here, then I would have D times V. And then if I want to solve for volume, I would cover the V up, and then I would have our mass divided by our density. So you can use this magic triangle to help you solve for either one of these or any of these units. And then our units for density, first thing is going to be mass is going to be measured in grams. Then our volume is going to be measured in milliliters or cubic centimeters. Remember, milliliters if the substance is a liquid, and cubic centimeters if the substance is a solid. And then our unit for density is grams per milliliter if it's a liquid, or grams per cubic centimeters if the substance is a solid. So I go ahead and note that right down here at the bottom as well, so no one will get confused on these concepts. Practice time, and you're going to use your knowledge and notes of density to solve the following problems. And since I love density so much, I'll go ahead and help you out with the first one. So number 1, we're going to calculate the density of a rock that has a mass of 1800 grams. So let me go ahead and circle that 1800 grams. Identify that component down here. And then it has a volume of 100 cubic centimeters. And since it's cubic centimeters, that lets me know it's a solid. And does the rock sink or float in water? So I know that we're solving for density. In order to solve for density, we do our mass divided by our volume. So 1800 grams divided by 100 cubic centimeters, that should give us 18 grams per cubic centimeters. And then the second part of this is, does the rock sink or float in water? Remember, if it has a density greater than 1, it's going to sink in water. So I'm just going to go ahead and write sink over here to the side, because 18 grams per cubic centimeter is much larger than the number 1. So ladies and gentlemen, you're going to take a minute to answer problems 2 and 3, and make sure you use your density triangle over here to the right. And I'll go ahead and give you that minute, and I'll come around to your desk and check and make sure that you're on point. Now let's take a look at our second way to solve for density. So a problem may give you the density or the mass, but you may have to calculate for volume. And this is pretty simple. So for example, a box is 4 centimeters in height, 3 centimeters in length, and 2 centimeters in width. And what we're going to do is going to multiply all 3 numbers to get the volume in cubic centimeters, and that should give us 24 cubic centimeters. And once we have the volume, then we can solve for density. So let's go ahead and look at a practice problem for that. So a box has a height of 3 centimeters, length of 4 centimeters, and width of 5 centimeters. It has a mass of 15 grams. What is its density? And will the box sink or float in water? First of all, we have to solve for our volume. So we're going to take that 3 and multiply it by 4, which is going to give us 12. Then 12 times 5 is going to give us 60 cubic centimeters. And I'll go ahead and put it down here as well for 60 cubic centimeters for our volume. So now that we solve for our volume, it says that it has a mass of 15 grams. So now we can go ahead and take our mass and divide it by our volume, and we're going to take 15 grams divided by 60 cubic centimeters, and that should give us a density of 0.25 grams per cubic centimeters. And the second part of this question is it going to sink or is it going to float? Remember, if it has a density greater than 1, it's going to sink. But if it has a density less than 1, it's going to float. And if you notice, 0.25 grams per cubic centimeters is at a density less than 1. So this box is actually going to float. And now let's take a look at our third way to solve for density, which is the water displacement method. So a problem may give you density or mass, but you may have to solve for volume once again. So the water displacement method is going to be our amount of water with the object in it minus our amount of water without the object in it, and that's going to give us our volume. Once we get our volume, once again, we can go ahead and divide our mass by our volume to get our density. So let's go ahead and practice. It says a graduated cylinder has a volume of 20 milliliters without a rock in it, and a volume of 32 milliliters with the rock in it. And then it says the rock has a mass of 14 grams. What is its density, and will the rock sink or float in water? So I'm going to take my final volume, which is 32 milliliters, minus my initial volume, which is 20 milliliters, and I'm going to subtract. So my volume ends up being 12 milliliters. So I have 12 milliliters right here. And then in the problem it says that it's 14 grams. So in order to solve for our density, I'm going to take my mass, which is 14 grams, and I'm going to divide it by my volume, which is 12 milliliters. And 14 divided by 12 is going to give us 1.2 grams per milliliter. And I'm going to go ahead and put that over here as well. So 1.2 grams per milliliter. But since we're talking about a rock is a solid, so it should be 1.2 grams per cubic centimeters. Now the second part it asks us is, will the rock sink or float in water? The rock has a density greater than 1, so that rock is going to sink in water. Now let's do some more practice using our water displacement method, and you're going to use your notes to solve the following problems. And I'll go ahead and help you out with the first one. So if you notice, the amount of water with the rock in it, that's going to be our VF, our final volume. And then the amount of water without the rock in it, that's going to be our VI, or our initial volume. Remember, you're going to subtract your final volume minus your initial volume to get that volume. And then once you get your mass, you can solve for density. And you're going to do the same for problems number 2 and 3, and I'll give you a minute to do so. So go ahead and knock out problems 2 and 3, and I'll come around to your desk to make sure you're on point. Ladies and gents, you're now going to read the substance density chart to the right and answer the following questions over here to the left. And so for example, number 1, which substances will sink in water? Well, I definitely know that glycerin is going to sink in water. How do I know? You go ahead and tell me how do I know. But you're going to take another 2 minutes to answer the following questions using this density chart and your conceptual knowledge. So go ahead and pause the video and get started, and I'll check back with you shortly. Time for our final check for understanding. And you're going to put it all together by solving the following density problems. And remember, don't forget to put your units and write whether the object will sink or float in water. Once again, I'm Coach Spivey, joining my son Jordan Spivey. And if you haven't already, go ahead and like and subscribe to our channel so you don't miss out on our amazing science tutorial videos. And also go ahead and check us out at our website at www.fathersoninnovations.com, and I'll leave a link in the description below. And like I always say, make sure you have a wonderful, awesome, positive day. Peace.